100 Facts About the Continental Drift to Fall Asleep To. Part 1. The Pace of a Lifetime. Fingernails and Foundations. Close your eyes, if you like, and think of your hand. Think of the very tips of your fingers and the quiet, constant work happening there, right now. In the time it takes for you to grow your fingernail by just 1 single millimeter, the continent you are sitting on has moved the exact same distance. This is our starting point, the pace of the great dance. Imperceptible in a day, a month, a year, but measured in a lifetime, it tells a story. So, let us measure it. Let's imagine a lifetime, say, 80 years, and watch what this gentle, relentless movement means. The year is now. A child is born in Lisbon, on the edge of the Eurasian plate, and at the very moment she takes her first breath, the Atlantic Ocean is a little wider than it was for her great-grandparents. The Atlantic Ocean is still growing, because the mid-Atlantic ridge is constantly creating new oceanic crust. It pushes the Americas away from Europe and Africa at about the speed your nails grow. 2.5 centimeters or 1 inch per year. This great underwater mountain range runs like a zipper down the ocean spine. Here, the Earth's crust is pulling apart, and magma rises to fill the gap, cooling into new rock. It is the engine of the Atlantic. And in our lifetime, that ridge will have added nearly 2 meters of new ocean floor. The entire Atlantic basin will be about 2 meters wider than the day our person in Lisbon was born. As she learns to walk on the stony beaches of Portugal, her feet are touching ancient travelers. The rocks here may have stories from another hemisphere. The Appalachian Mountains in North America and the Caledonian Mountains in Scotland and Norway are the same mountain range, torn apart some 300 million years ago. You can match their rock layers like pages of a ripped book. Two halves a whole, now separated by an ocean that did not exist when they were born. In a single human lifetime, they drift just a little farther apart, a quiet, permanent farewell. All of Earth's landmasses were once joined in a single supercontinent called Pangaea. It began breaking up about 175 million years ago. Our human timescale is but a single, slow blink in that long separation. And the breakup is not over. The continents are still moving, carried on great rafts called tectonic plates. The Earth's lithosphere, the crust and upper mantle, is broken into 7 or 8 major plates and many minor ones. They float on the ductile, flowing asthenosphere beneath. It's not the continents moving through the oceans. It is the entire plate, ocean floor and all, moving in a grand, unified drift. Lisbon, the Atlantic seafloor beside it, and the mountains inland, they are all one passenger on the Eurasian plate. Because of this drift, the flight from Europe to North America takes slightly longer today than it did for Charles Lindbergh in 1927. The extra distance he would not have had to fly, about 4 meters. A tiny amount for a plane, but a monumental shift for the planet. And below that flight path, on the ocean floor, lies evidence of this endless conveyor belt. The oldest oceanic crust is only about 200 million years old, while continents can be billions of years old. This is because old ocean floor is constantly being recycled back into the earth at deep ocean trenches, in a process called subduction. The Atlantic is young and opening. The Pacific is ancient and closing. In a lifetime, a trench like the Mariana Trench deepens by mere centimeters, swallowing an ocean floor that was itself born at a ridge like the one in the Atlantic. The stability of the continents is an illusion. The bedrock beneath our cities, our homes, our feet is in constant, slow motion. The North American and Eurasian plates are moving apart roughly as fast as your hair grows. And this movement is not always smooth. It sticks and builds tension and releases. Most of the world's earthquakes and volcanoes occur along the boundaries of these tectonic plates. The grinding, sticking, and sudden slipping of plates is what shakes the ground. But here, on our stable seeming continent, far from the edges, we feel only profound peace of the great, slow ride. In her 80 years, the Atlantic has widened by about 2 meters, a pace you could not see or feel, but a distance you could, with arms outstretched, just about measure. This dance continues unabated. Australia is moving northward about 7 centimeters per year, the fastest of any continent. India, once a separate island, crashed into Asia at the slow, unstoppable pace to raise the Himalayas. So as you rest now, know this: the solid ground is a traveler. Your lifetime is a single note in a symphony of stone and magma, playing over hundreds of millions of years. And it all happens about as fast as your fingernails grow. Part 2. The map of fire, boundaries, collisions, and the ring of fire. If we could pull back the oceans and see the Earth not as a map of nations, but as a map of its living, moving shell, this is what we would see: a luminous puzzle, a cracked eggshell floating on warmth. The Pacific Ocean is surrounded by what is called the ring of fire. This is not a single ring, but a connected series of oceanic trenches and volcanic arcs where several plates are being subducted, swallowed back into the Earth's mantle. Most of the world's volcanoes live here. It is here that the great oceanic plates, the Pacific, the Nazca, the Cocos, meet the continental plates and bend, diving down into the depths. This is where ocean floor, born at ridges in the middle of seas, goes to die, a cycle older than bones. The Andes, the longest continental mountain range in the world, are a direct result of this process. The Nazca plate is sliding beneath the South American plate, crumpling its edge and pushing the land skyward. In a human lifetime, the Andes rise by a few centimeters. Visuals: a breathtaking time-lapse view of mountains rising. But the time-lapse is so slow that a cloud formation passes in real time over the seemingly still, yet incrementally ascending peaks. Think of a rug pushed against a wall. It wrinkles, it folds, it piles up. The Earth does the same, but with rock. And it does it so slowly that the erosion from rain and wind constantly tries to wear it down. Their height is a conversation between uplift and erosion, a conversation where every sentence lasts 1,000,000 years. Japan exists because of subduction. It is a volcanic island arc, a chain of mountains born from the melting of the Pacific plate as it dives beneath the Eurasian plate. The very ground of Japan is made from the recycled remains of an ancient ocean floor. The land is born from the ocean's descent. It is a phoenix made of rock. In a lifetime, these islands might grow a little wider from volcanic deposits, or shift a few feet east or west after a great tremor settles the built-up strain. They are never still. The collision that built the Himalayas is the most dramatic slow-motion crash on Earth. The Indian subcontinent, once an island drifting northward, met Asia about 50 million years ago. It has not stopped moving. It is still pushing north into Eurasia at about 5 centimeters a year. This is not a collision that happened once. It is a collision that is happening now, every minute of every day. For the entire span of human civilization and long before, India has been applying gentle, unimaginable pressure. In 80 years, it travels about 4 meters farther into Asia, the height of a room. Mount Everest and all the Himalayas are still rising. The ongoing push of India lifts them by about 1 centimeter per year, but they're also being weathered down. The race between creation and erosion is nearly balanced. So, the highest point on Earth is not a fixed place. It is a moment in a tug of war. It is a summit that is both growing and dissolving, a fleeting crown made of stone. Not all plate boundaries are colliding or pulling apart. Some simply slide past one another. The San Andreas Fault in California is a famous example, where the Pacific plate slides horizontally past the North American plate. In a lifetime, points on opposite sides of the fault shift by several meters. It is a sidestep, a slow-motion scrape that builds tension until it releases. The land does not tear open and swallow places whole. It just ensures that, over centuries, a venue will no longer align with the post office it was built to serve. Africa is being slowly torn apart. The East African Rift Valley is a place where the continental crust is stretching and thinning. In millions of years, this rift may become a new ocean, splitting a piece of eastern Africa away from a main continent. Here, a new ocean is being dreamed into existence. The heat from the mantle is doming the land upward, and gravity is causing to stretch and fracture. In a human lifetime, the rift widens by a few millimeters, a crack in a sidewalk over a long summer. But give it time, and a sea will fill it. And what force is great enough to move entire continents? to split oceans and raise mountains that touch the sky. The engine of plate tectonics is the Earth's internal heat, left over from its formation and generated by the radioactive decay of elements in its core. This heat sets the mantle rock in motion through a process called convection. The plates are simply the surface expression of this deep internal circulation. They are the skin on a pot of gently simmering soup. Carried on these slow rivers of rock are our lives, our histories, every city and forest. So when she looks at the stars tonight, her solid ground is not still. It is riding a current of stone, flowing from a ridge in the middle of an ocean, towards a trench at the edge of a continent, or towards a collision with another landmass. In her lifetime, she has journeyed thousands of kilometers on this raft, not by walking, simply by being. Part 3. The hidden landscape, from ridges to trenches, the ocean floor's brief life. The true stage for this great drift is not the land, but the hidden seafloor, a landscape more rugged than any mountain range on the continents, yet almost entirely unseen. The global mid-ocean ridge system is the longest mountain range on Earth, stretching over 65,000 kilometers. It winds around the planet like the seam on a baseball. Yet, we have mapped the surfaces of Mars and the Moon in more detail than this, our own planet's greatest physical feature. These hydrothermal vents, or black smokers, are direct portals to the tectonic engine. Seawater seeps into cracks in the new oceanic crust, is superheated by magma, and jets back out, laden with minerals. They support entire ecosystems that exist not by sunlight, but by chemosynthesis. Life here is born from the rock and the heat. It is a testament to a planet that creates not just landscapes, but the possibility for life from its own internal fires. In the time it takes for a human to live a full life, a vent field might grow a chimney as tall as a building, or collapse into a silent pile of ore. The abyssal plains are flattest, most featureless places on Earth. They are made of sediment, the slow, constant rain of dust from continents and the microscopic shells of plankton that has settled over millions of years, burying the rugged volcanic landscape underneath. This sediment accumulates at a rate of about 1 to 5 centimeters every 1,000 years. Imagine snowfall where each flake takes a century to fall. That is the making of the abyssal plain. In a lifetime, less than a millimeter of this fine dust settles. It is the quietest library on Earth, writing its history in layers thinner than paper. The famous Ring of Fire, volcanoes are mostly stratovolcanoes, like Mount Fuji or Mount Rainier. Their elegant, conical shapes are built layer by layer, eruption by eruption, from sticky, gas-rich magma. A single volcano may take hundreds of thousands of years to build, but can be dormant for just as long. A human generation might see only stillness from such a mountain. A lifetime might see a single small eruption that adds a footnote to its story. The mountain holds its breath for centuries, then exhales, gently reshaping its own silhouette. The Hawaiian Islands are not born from clashing plates, but from a hotspot, a stationary plume of exceptionally hot rock rising from deep within the mantle. As the Pacific plate moves northwest over it, the plume punches through, creating a chain of volcanic islands. We can see the plate's movement written in the island chain itself. The Big Island of Hawaii is currently over the hotspot and active. To the northwest, Maui, Oahu, Kauai are progressively older, more eroded and extinct. The chain continues underwater as the Emperor seamounts, making a sharp bend that records a change in Pacific Plate's direction 47 million years ago. It is a timeline drawn on the ocean floor, a receipt for the journey. The islands are not moving. The ground beneath them is. The newest island, Loihi, is already building its summit 1,000 meters below the waves off Hawaii's coast. It may break the surface in 10,000 or 100,000 years. A future landmass, already being dreamed of in the deep. The deepest point on Earth, Challenger Deep, is a direct result of subduction. Here, the old, dense Pacific plate bends and plunges into the trench. At nearly 11 kilometers deep, the pressure is over 1,000 times at its sea level. This is where the ocean floor's long journey ends, in a silence and darkness more absolute than anywhere else. In a lifetime, this trench deepens by a negligible amount. It is a monument to consumption, to the Earth reclaiming its own skin. So the seafloor is born in fire of the ridges, travels across the abyssal plains under a rain of dust, and is consumed in the crushing dark of the trenches. Its entire life cycle, from creation to destruction, is rarely longer than 200 million years. A continent may remember the dinosaurs, but the ocean floor beneath you remembers only the early mammals. Part 4. Echoes of Ancient Worlds, Supercontinents, Magnetic Memories, and the Oldest Stones. To understand the dance, we must listen to its oldest rhythms. The continents we know are not the first. They are merely the latest verse in a very long poem. Pangaea was not the first supercontinent. Geologists believe there is a cycle, called the supercontinent cycle, that assembles and breaks apart landmasses every 300 to 500 million years. Before Pangaea, there was Rodinia, which existed about 1 billion years ago, and before that, possibly Nuna or Columbia. Imagine a world where the map was a single, lonely continent. No Atlantic, no Pacific as we know it. Just one vast land, under a younger sun. The life that existed then, simple, microbial mats in shallow seas, would have seen a shore that stretched beyond any horizon. The Earth's magnetic field, generated by the churning of molten iron in the outer core, has reversed hundreds of times in the planet's history. When new volcanic rock forms at mid-ocean ridges, it records a magnetic field erection as it cools, creating a permanent tape recording of these reversals. This magnetic striping on the ocean floor was one of the key pieces of evidence that proved the theory of plate tectonics. It showed that new seafloor was being created symmetrically, pushing older crust away from the ridge. It is the most definitive proof that the ocean floors are moving. So, the seafloor is not just a landscape. It is a history book, an archive of the Earth's restless core, printed in stone. In a single human lifetime, the field doesn't reverse. It merely wobbles, weakens slightly, a breath held before an eventual, inevitable sigh that will take 1,000 years to complete. Some of the oldest rocks on Earth are found on the continents, in cratons, the ancient, stable hearts of tectonic plates. The Jack Hill zircons in Western Australia contain crystals that are about 4.4 billion years old, only 160 million years after the Earth formed. This tiny grain of sand holds a memory older than oceans, older than air. It crystallized from a magma ocean on a planet that was still being assembled. It has survived every supercontinent cycle, every collision, every erosion. It has been part of mountains that have vanished and now rests in this quiet desert. In your hand, you can hold a piece of the Earth's first solid skin. The very ground beneath places that feel perfectly stable tells a story of incredible journeys. The sedimentary rocks of the Midwest, the limestone of great inland seas, are made of material that was eroded from ancient mountain ranges like the Appalachians, which were themselves built by continental collisions hundreds of millions of years ago. The soil that grows the wheat, the stone that builds a barn, it is all traveler's dust, the ghost of the mountain that disappeared before the dinosaurs walked. The continent is a canvas, constantly being painted over. The old landscapes are never truly gone. They are just ground down and redeposited, whispering in the geology. Even caves are a record of tectonic and climatic history. Their formation depends on water flowing through soluble rock like limestone, which is itself made from the skeletons of ancient marine life. The rate of stalactite growth, about 1 centimeter every 100 to 200 years, is a clock measuring the patient work of water on land shaped by ancient seas. In a lifetime, a stalactite might grow the length of a fingernail. It is a counter-rhythm to the uplift of mountains. As land rises, water seeks to dissolve it, to lay it down again. The continent breathes in, building high. The water breathes out, carving deep. The Alps, like the Himalayas, are the product of a continental collision. In this case, it is the northward movement of the African plate, pushing into Eurasia. This collision is younger than the Himalayan one, and the Alps are still rising, though erosion claws at them fiercely. Europe is not a passive stage. It is an active sculpture, being squeezed from the south. The movement is slow, but its consequences written in the sheer faces of the Matterhorn, in the deep valleys where villages cling. In 80 years, the Alps ascend a few centimeters closer to the sun, while glaciers scrape them back down. And as she shows her grandchild the patterns in the stars, the pattern beneath them is shifting. The ground that holds their seats is part of a story so long, it makes human history seem like the blink of an eye. We mark our lives by seasons, by years. The Earth marks its life by the assembly and dispersal of continents. Our lifetime is a single, quiet beat in that rhythm. Part 5. The engine of stone, mantle currents, slab pull, and the breath of mountains. We have seen the dance from above. Now, let us sink into the source of the music. Beneath the rigid plates lies the mantle, not molten but plastic, solid, yet flowing over ages. This is where the journey truly begins. The journey of a convection current, from the hot core mantle boundary to the cold surface and back again, can take hundreds of millions of years. A parcel of mantle rock that rises to form a mid-ocean ridge today may have last seen the surface when the supercontinent Pangaea was just beginning to rift. The rock that fuels the engine of the Atlantic ridge is ancient beyond comprehension. It has been circulating in the dark for longer than flowers have existed on Earth. Its ascent is the planetary equivalent of a single, deep breath. The force that actually moves the plates is a combination of this mantle convection and the plate's own weight. At mid-ocean ridges, the new, hot crust is elevated. Gravity then pulls it down the gentle slope away from the ridge, a process called ridge push. At subduction zones, the cold, dense oceanic slab sinks into mantle, pulling the rest of the plate behind it like an anchor. Slab pull. Slab pull is considered the most powerful driver of plate motion. A subducting plate can be thought of as the engine's piston, its descent dragging the entire system along. So the plates are not just passengers on convection currents. They are active components of the machine. Their own cold, heavy edges become the weight that drives the conveyor belt. They are both the cart and the horse. When continents collide, their light, buoyant crust does not easily subduct. Instead, it crumples, folds, and thickens. This creates not just mountains, but deeply buried rocks that are transformed by heat and pressure into entirely new forms, metamorphic rocks. The minerals in these metamorphic rocks act like tiny recording devices. By studying them, geologists can determine the precise pressure and temperature the rock experience, allowing them to reconstruct the depth and intensity of ancient mountain-building events, long after the mountains themselves have eroded away. The Himalayas are not just peaks. They are an open book of pressure and time. You can read in the sparkle of a stone a chapter that says, "Here, 30 kilometers down, 50 million years ago." The mountain's root is still there, telling its story. Not all tectonic change is violent uplift. Sometimes it is a gentle sinking. Some coastlines are slowly subsiding due to tectonic settling or the weight of sediment from great rivers. The Bahamas, for instance, sit on a slowly sinking carbonate platform. Their existence is a race between the growth of coral reefs and the gradual drowning of their foundation. Here, life is building a fortress against a sinking land. Polyp by polyp, the coral keeps pace with the imperceptible descent. In a lifetime, the subsidence is less than the height of a coin, but over millennia, it dictates the fate of islands and ecosystems. The location and size of the world's great river deltas are directly controlled by tectonics. A delta persists where a river brings sediment faster than local currents can wash it away, often in passively subsiding basins at the edges of continents. If the plate shifts or the basin fills, the delta will migrate, abandoning old channels. The mud and silt that builds a delta, that creates vast fertile farmland, is only there because the land is subtly giving way. Civilization flourishes in the sediment that fills a tectonic trough. The stone she schemes came from a mountain that may no longer exist. It was tumbled in a river whose course has changed. It was ground smooth on a shore that is slowly sinking. Its journey is a miniature of the continent's journey. Earthquakes are the sound of the plates moving, not the slow drift, but the sudden jerk when friction is overcome. The seismic waves from a large quake can ring through the entire planet, like striking a bell. Seismologists use these waves to create images of the Earth's interior, much like a doctor uses an ultrasound. So each tremor, however destructive, is also a moment of illumination. It sends whispers through the body of the Earth, and by listening, We learn the shape of it hard. From the core's heat to the ridge's fire, to the slab's cold pull, to the mountain's fold, to the delta's silt, to the quake's tremor, it is all one connected system. A single great mechanism, breathing over billions of years.
Part 7. Written in stone. Deserts, rift valleys, and the grammar of landscape. The most unchanging landscapes are often the most transient. Deserts are not just places. They are events. They are the consequence of rain shadows, of continentality, of the drifting of land into the silent zones of global wind patterns. They are born from the dance. The location of the world's great deserts is often dictated by tectonics. The Himalayas, raised by India's collision, created the massive rain shadow that formed the Gobi and Taklamakan deserts in Asia. The Andes do the same for the Atacama, the driest place on Earth. A desert can be the downstream consequence of a mountain range born from a collision on the other side of the continent. A grain of sand in the Sahara may have begun as a crystal in the heart of the rising Alps, freed by erosion, and carried by winds whose very path was altered by the shape of the land. Some of the most surreal landscapes on Earth are the result of trapped seas. Vast, ancient lakes or small inland seas, formed in tectonic basins, eventually evaporate, leaving behind thick plains of salt and mineral deposits. These evaporite basins are a direct signature of the opening and closing of continents. The salt under your feet was once an ocean, a tear of the Tethys, or a young gulf, caught and left behind as the land changed around it. It is a ghost of vanished water, a chemical memory. Iceland is one of the only places on Earth where a mid-ocean ridge is exposed above sea level. This is because it sits directly atop the mid-Atlantic ridge and a mantle hotspot. The combination of spreading and excessive volcanism has built a unique island where you can stand between two tectonic plates. Adding Veller, you can literally walk through the Rift Valley between the plates. The gap widens by about 2.5 centimeters per year. The ground here is not splitting in human time, but it is stretching, a constant, gentle tension you can see in the very shape of the land. Here, the planet's seams are visible. You can touch the wall of a continent. In a lifetime, the valley widens by the length of your arm. It is a place that makes the abstract profoundly physical. The composition of volcanic rock tells a story of its origin. The dark, runny basalt of Iceland and Hawaii comes from the mantle. The lighter, stickier andesite of the Ring of Fire is melted continental crust, recycled in the subduction zone. Each lava is a coded message about the depth and history of its melting. The Earth does not have one recipe for rock. It has a cookbook, and the chapter it chooses depends entirely on where it is in the Great Convective Kitchen. The law of superposition is a simple, powerful idea. In an undisturbed sequence of sedimentary rock, the oldest layers are at the bottom, the youngest at the top. This simple rule, applied to the Grand Canyon or to oceanic sediment cores, allows us to read Earth's history like the pages of a book, from the most recent chapter back to the earliest. The canyon is a timeline made of stone. Each band of red or gray is a world, a desert, a shallow sea, a river delta. They are the accumulated moments of hundreds of millions of years, lifted up by the deep forces of the continent and then opened like a gift by the patient Colorado River. Her hand touches a library. The rough granite, a piece of an ancient Pluton, cooled slowly deep underground. The smooth sandstone, a beach from a Jurassic sea, now hardened. The brittle slate, a mud from a quiet lagoon, heated and pressed until it could split into sheets. Every stone in a wall, every pebble in a path, is an artifact of tectonic history. They are fragments of journeys, of subduction zones, of mountain routes, of ancient floors. To hold a rock is to hold a passport stamped with events you can only imagine. We live our lives surrounded by these souvenirs. We build our homes from them. We are the temporary inhabitants of a world built from its own magnificent debris. The story is in the stones. It is in the salt flats and the sand dunes, in the Rift Valley and the canyon wall. It is written in the very stuff of the world, waiting for a patient eye, a curious hand, a lifetime of quiet attention to begin to read it. Part 8. Cities on the Move. Human worlds built on a shifting stage. We have built our civilizations upon this drifting stage. Our maps are drawn in ink and light, but they are laid over a map written in rock and motion. And sometimes, the two maps speak to each other. Many of the world's great cities are built directly atop or perilously close to active plate boundaries. Their locations, often on natural harbors, river mouths, or fertile plains, were chosen for trade and sustenance, little knowing they were also places where the earth breathes most deeply. The vibrancy and the vulnerability are two sides of the same tectonic coin. A city can be a bridge between continents, a meeting of worlds, because the land itself is in conversation there. The drama of human history unfolds on a stage that is, itself, in slow-motion drama. Not all land is rising. Some is sinking and not from ice. The forebulge effect, land that was pushed up at the edges of ancient ice sheets during the last ice age, is now slowly settling back down. Meanwhile, land that was depressed at the ice sheet center, like parts of Canada and Scandinavia, is now rising. This glacial isostatic adjustment is a slow, continent-scale sigh of relief after a heavy weight was lifted. The ground beneath a windmill in Holland sinks by millimeters each year, a lingering echo of ice sheets that melted 10,000 years ago. The planet's memory is long, and its adjustments are patient. Sometimes, the deep earth is thrust to the surface. In a few rare places, like Oman or Cyprus, slivers of the Earth's mantle, the dense, green rock called peridotite, have been pushed up onto the continents. These ophiolite suites are pieces of lost oceanic crust and upper mantle, offering a window directly into a world usually hidden beneath 7 kilometers of water. This is the Earth's interior, worn as a trophy on its sleeve. To touch this rock is to touch the material that feeds the volcanoes at the mid-ocean ridge. It is a piece of the engine, now silent and exposed to the air. Individual mineral grains can act as paleopiezometers and paleothermometers. By analyzing the distortion in their crystal lattices or the chemistry of their inclusions, scientists can deduce the colossal pressures and temperatures the grain endured, pressures equivalent to being buried 100 kilometers deep, temperatures that would melt rock at the surface. A single crystal, smaller than a grain of sand, can hold the memory of a depth beyond our reach. It is a witness to the mountain's root, to the subduction zone's grip, now telling its story in the quiet hum of an electron microscope. The oldest oceanic crust on Earth is found in the western Pacific, near the Mariana Trench, and is only about 200 million years old, Jurassic period. In contrast, the oldest continental crust is over 4 billion years old. This stark difference is the clearest evidence of the rock cycle. Ocean floor is recycled, while continents, being lighter, are eternal fugitives, collecting and preserving history. The ocean floor is the Earth's living skin, constantly renewing itself. The continents are its scars, its memories, its heirlooms, forever being reshuffled, but never truly destroyed. Not all fault lines are dramatic scars. Many are hidden, their evidence subtle, a sudden straight valley, an oddly aligned series of ponds, a gentle, linear step in the landscape only visible with a keen eye or from the air. The land remembers the break, even when the forest tries to heal it. The earth forgets nothing. A fracture from a quake 1,000 years ago is still written in the lay of the land, in the path of a stream, in the way the trees line up. It is a ghost in the topography. From here, the story becomes clearer. The long, straight line of a river following a fault. The circular intrusion of an ancient volcano, now a ring of hills. The perfect curve of a bay, carved where softer rock met a harder, more resilient plate. Landscape morphology, the very shape of hills, valleys, and coastlines, is the ultimate synthesis of tectonics and climate. Tectonics creates the bumps, the potential energy, and climate, through water and ice, sculpts them, the kinetic energy. Every vista is a finished sentence in that endless dialogue. We see beauty. Geology sees grammar. The poetry of a place is written in the language of stress, strain, uplift, and erosion. And for a moment, between the land and the sky, we are suspended in the present. But the ground below and the mantle below that are engaged in a past that is still unfolding, a future that is already being written in the slow convection of stone.
Part 9. The Interconnected Breath. How the dance drives ocean, skies, and life. The dance of the continents is not an isolated rhythm. It is the bass note in a symphony that includes the sky and the sea. For the shape of the land directs the currents of the ocean and the passions of the atmosphere. The global ocean conveyor belt, the great system of thermohaline circulation that moves heat around the planet, is fundamentally shaped by the placement of the continents. The Drake Passage, the gap between South America and Antarctica, allows the unimpeded flow of the Antarctic circumpolar current, the mightiest current on Earth. If the continents were arranged differently, our climate would be unrecognizable. That lonely, furious current exists because a continent drifted away from another, opening a gate. The cold, deep breath of the planet is possible because of a divorce that began 30 million years ago. Visuals. We descend from the global view to a specific coastline where a cold, nutrient-rich current wells up against the continental shelf, the coast of Peru or California. Upwelling zones, some of the most biologically rich areas in the ocean, are often created by winds that blow along coasts, which are themselves shaped by plate tectonics. The cold water from the depths brings nutrients, feeding phytoplankton, which feed the entire food web. The abundance of life in certain seas is a gift of the land's configuration. A billion fish dart in a glittering cloud, because a continent sits in a certain place, guiding a wind, drawing up food from the abyss. The dance of continents writes the menu for the sea. The shallow, warm, sunlit waters of continental shelves are the nurseries of the ocean and the primary sites for carbonate deposition. The slow, steady accumulation of trillions of shell creatures remains here, over millions of years, creates the limestone that will become the future bedrock of continents. Life builds the stage for future life. The skeletons of the tiny build the foundations of the vast. The shallow seas that fringe the continents are factories of future stone. In a human lifetime, a layer thinner than a leaf is added, but given time it becomes a cliff, a cave, a cathedral. The chain of volcanoes that forms above a subducting slab is not random. They line up in a curve, parallel to the trench. The distance from the trench to the volcanic arc is determined by the slab's angle of descent. A steeper slab pulls the volcanoes closer to the coast. A shallower slab pushes them farther inland. It is geometry written in fire. The volcano's address is calculated by the slab's plunge into the hot mantle. It is a predictable result of an immense, hidden geometry. The mountain's location was decided 100 kilometers below, 10 million years before it was born. Some of the most serene landscapes are the graves of catastrophic violence. Calderas, like Crater Lake in Oregon or Lake Toba in Indonesia, are formed when a massive volcanic eruption empties a magma chamber, causing the ground above to collapse into the void. This is a tectonic cycle at its most abrupt, rapid collapse after a furious upwelling. The violence passes. The earth heals with water and silence. What was once a fountain of fire becomes a basin of perfect reflection, holding the clouds. The memory of the violence is preserved only in the stunning depth of the water. The existence of the highest, driest places on Earth, ideal for astronomical observatories, is a direct tectonic product. The Atacama Desert is hyper-arid because it is in the double rain shadow of the Andes and the coastal range, a topography created by subduction. The thin, dry air there allows us to see the universe with crystalline clarity. To see the farthest stars, we stand on the driest ground. And that ground is dry because of a plate diving into the mantle. Our window to the cosmos is framed by the collision of continents. She holds a stone, its surface smoothed by a river that no longer flows, warmed by a sun that has shone on it for an eon. It connects her to everything. The oxygen we breathe is intimately tied to tectonics. The long-term carbon cycle, which regulates Earth's climate, is controlled by the weathering of silicate mountains, which pulls CO2 from the air, and volcanic outgassing, which adds it. This balance, maintained over millions of years by the constant remodeling of continents, helped create the stable, oxygen-rich atmosphere that complex life required to evolve. The very air is a product of the dance. The mountains break down and clean it. The volcanoes replenish it. We breathe because the continents move. And in this final quiet, the scale resolves. The lifetime, the stone, the mountain, the continent, the mantle, all are connected. All are part of the same slow, magnificent story of a living planet. Part 10. The Witness and the Voyage, from a grain of sand to a living planet. And so, we reach the final measure of our lifetime, 80 years. In the language of continents, it is a single, quiet breath, but a breath in which an astonishing amount has transpired, quietly, beneath the threshold of sight. The sand grain, it could be quartz, whether from a granite born in a continental collision hundreds of millions of years ago. It has been ground down from mountains, carried by rivers whose courses were dictated by faults, deposited on a shore whose very existence is shaped by the subsidence or uplift of a tectonic margin. Its journey is a biography of the continent. This one grain. In a lifetime, a continent moves about 2 meters. How many grains of sand are in 2 meters of a beach? Each one with a story just as long. The distance traveled is not a span of emptiness, but a distance filled with the ground-down histories of ancient worlds. The 2 meters the Atlantic widened in our protagonist's lifetime, that is New Earth. It is basalt that did not exist when she was born. It crystallized from the mantle, was quenched by seawater, and now forms part of the planet's ever-renewing skin. We live on a planet that is still creating itself. The world she leaves is physically larger than the world she entered, by a sliver, by a breath. This movement is no longer just inferred from ancient rocks. It is measured daily. Networks of GPS satellites and ground stations track the drift in real time. We know Perth, Australia, moves north by about 6 centimeters per year. That North America rotates slowly westward. That India continues its relentless push into Asia. We have instruments that can hear the whisper of the mantle. The dance is a present tense fact, monitored by beacons whose precision is the fruit of a lifetime of human curiosity. We are the first generations to watch the plates move. Using this data and the principles of plate tectonics, scientists can project a map of the world tens of millions of years into the future. They forecast the closure of the Mediterranean, the collision of East Africa with Asia, the northward march of Australia into the tropics, and the formation of a new mountain range where the Atlantic may one day begin to close. The future is already written in the momentum of the plates and the geometry of the ridges and trenches. We are living in a specific, fleeting chapter of story whose outline we can now read ahead. The elements in that stone, in that plant, in our own bodies, the iron in our blood, the calcium in our bones, were forged in stars and delivered to a young Earth. Tectonics, through volcanism, hydrothermal vents, and the creation of continents, concentrated these elements, cycled them, made them available for life. We are not just living on the moving continents. We are made from them. We are the thinking part of the rock cycle. We are transient arrangements of ancient, well-traveled matter. The continents are the stage, the cupboard, and the archive for the stuff of us. The final, beautiful interconnection, the rock cycle and the water cycle are one system. Water weathers mountains. Rivers carry sediment to the sea, where it forms new rock. That rock is subducted, and volcanoes release the water back into the atmosphere as vapor. The continents drift, the rains fall, the mountains wear down, and the water is recycled to the fiery mantle. Nothing is lost. Everything is transformed into a grand, cosmic reciprocity. It is a single, closed loop of breathtaking elegance, the pulse of the planet. The continents are not just drifting, they are breathing, with a breath that lasts 100 million years. Our entire tectonic system exists within a vaster voyage. The sun, with its family of planets, orbits the galactic center. In a human lifetime, the solar system travels over 5.4 billion kilometers through space. The continental drift below is a tiny, local meander on a journey of unimaginable scale. We are carried on a plate, on a planet, in a solar system, in a galaxy, in motion. All is journey. The continental drift is merely the journey we can touch. The very existence of our life-sustaining atmosphere is intertwined with tectonics. The long-term stabilization of Earth's climate, the thermostat, is governed by the silicate weathering cycle, which pulls carbon dioxide from the air and by volcanism, which replenishes it. This balance, maintained by the constant churning of plates, prevented Earth from becoming a perpetual ice house or a runaway greenhouse. The dance of the plates is the guardian of our sky. The air we breathe, the climate that cradles us, is a delicate equilibrium maintained by the slow grinding of rock. Our stable haven is a gift of perpetual, managed change deep below. The present is the key to the past. This principle, uniformitarianism, pioneered by James Hutton, is a foundation of geology. The processes we see shaping the Earth today, erosion, deposition, volcanism, operated in the same gradual way in the deep past. The 2-centimeter annual drift we measure today is the same force that opened the Atlantic over 200 million years. We are not living on a dead relic, but on a living planet whose language of change has remained constant. The key to reading the epic poem of the Earth is to observe the quiet verse of the present. Every action we take, every structure we build, exists within this frame of imperceptible motion. The pipelines that cross faults, the tunnels through mountains, the foundations of skyscrapers on floodplains, all are designed with an understanding or an ignorance of the deep, slow time of tectonics. Our civilization is a temporary sketch on a shifting canvas. Our greatest works of stone and steel are but brief alignments with a force that will, given time, misalign them, bury them, or uplift them into ruin. We build in the moment between one tectonic breath and the next. Human history itself has been channeled by tectonics. Mountain passes determine migration routes. Fertile river valleys nurtured the first civilizations on sediment from rising mountains, or deposits, concentrated by hydrothermal activity, dictated the locations of mining and industry. The map of human endeavor is drawn over the tattoo of the tectonic map. Wars have been fought for valleys carved by faults. Cities have risen in harbors created by subsiding coasts. We have always been actors in a play whose set was built by the drifting continents. That stone is an heirloom of deep time. In the child's lifetime, the continents will move another 2 meters. The Atlantic will widen by the height of a door. The Himalayas will rise by the length of a finger. The process is indifferent, continuous, and magnificent. And so, the story is passed on, not as a list of facts, but as a perspective, a way of seeing the solid world as fluid, the permanent as transient, the familiar as profoundly strange and wonderful. We now understand Earth as a system, where the geosphere, hydrosphere, atmosphere, and biosphere are inextricably linked. The engine of this system is the heat from Earth's interior, expressed as plate tectonics. It is the beating heart of a living planet. This is the whole, the drifting continent, the growing nail, the falling rain, the breathing child, the erupting volcano, the orbiting planet, all are part of one thing. The story does not end. The dance continues. The Atlantic will widen for perhaps another 100 million years, then may begin close. Africa will split. The Mediterranean will vanish. A new supercontinent, which some call Amasia, may form in the distant future as the Americas, Asia, and Australia converge around the North Pole. This cycle of assembly and dispersal, the supercontinent cycle, has happened at least 3 times in Earth's past. It is a planet's long, slow heartbeat. We live in the dispersed phase after Pangaea. Each supercontinent assembly dramatically alters global climate, ocean circulation, and the course of evolution. They are turning points in the history of life itself. The continental crust we stand upon, this archive of Earth's history, is unique in the solar system. No other planet we know of has this persistent, buoyant, recycled granite-rich skin. It may be one of the key prerequisites for a long-lived, complex biosphere. The pace of drift is not constant. It can speed up or slow down based on the arrangement of continents, the efficiency of subduction, and the heat flow from the mantle. We are currently in a period of relatively fast plate motion. The energy that drives it all, the heat from radioactive decay in the core and mantle, is finite. Billions of years from now, as that fuel dwindles, the mantle will cool, convection will slow, and the great dance will gradually wind down. Volcanism will cease. The last earthquake will tremor. The continents will become still. But that day is so fantastically far in the future that it holds no practical dread, only a poetic perspective. For billions of years to come, the dance will continue. In the span of a single human curiosity, from Alfred Wegener's scorn hypothesis to the GPS-confirmed reality, we have learned to read this story. It is one of our species' greatest intellectual achievements. So, when you feel the need for stability, remember that the bedrock itself is in motion. Its stability is an illusion of our brief perception. True stability lies in accepting change, in finding peace in the endless flux, the pace of your fingernails, the pace of continents. This is not a coincidence of scale. It is a gift of perspective. It allows us to measure the immeasurable, to comprehend the incomprehensible, by tying it to the intimate rhythm of our own bodies. In your lifetime, you have traveled 1,000 kilometers on this raft of stone, not by walking, simply by being. You are here to witness a fragment of song. As you drift toward sleep, let this thought cradle you. You are resting on a living earth, a planet that breathes, grows, and remakes itself in time and rhythm as old as the sun. And the story continues. The plates drift, the nails grow, life endures. The quiet, powerful dance goes on.